From the beautiful studios of Way Happy, this is Mr. Meyer and 2.8 absolute value and inequality. So let's talk about solving equations that we've been doing, but now what if it's an inequality, which we've even done? You have a whole shaded region. Well, then let's make it a little step harder and add the words and or in there. So what could happen is that somebody could tell you like say they ask you to pick a number and they could be like, pick a number between 1 and 10 or 50 and 60. So you kind of have an option. You can pick something between 1 and 10, or you can pick something between 50 and 60. So we have to be able to, solve or show that region or explain those two regions of answers. Now they could also say they're like, all right, the number's got to be between 1 and 50, and it's got to be even. Right? They could give us that kind of restriction. So two things are happening that you have to satisfy to be an answer. So be careful. The words and or are very important. Or meaning you could be in either group, or and means you have to be in both of them. And that's a wee bit scary. All right, let's talk about this one. First, we see an or problem. This is called a compound inequality. That means y has two sets of answers. You can either be in this group or you can be in this group, and you're still good. You don't have to be in both of them. So solve it like normal, but you make sure you write the word or in between your answers. So this first one, I'm looking at the left side. I want to get y alone. So I'm going to just divide by 6 because they were multiplied. Boom, boom. I get y is less than -4, right? Then I put the word or in between, and then I solve the other side. So let's see, that's added. So I'm going to subtract it, and I'm going to have y is greater than or equal to -2. So here's our set of answers. You can either be less than -4, or you can be greater than -2. Graph it on a number line. It looks like this. So boom. I'm going to put -4 on my number line. -3. -2 is going to go on my number line. -1, 0. For some reason, I always like 0 on there. Open circle, like we talked about here on the -4. And since the variable is coming first, it's showing me which way to graph. So it's showing to the left, or just remember which way all the ones that are less than -4 are. Same thing here. I got -2. This is a filled in circle because it's equal to. And now I'm going to say everything to the right of that because everything greater than -2 is that way. And so there's your solution, right? And there's your graph. Now, a little heads up, the cool way to write the graphing when you get into pre-calc and stuff, and so I might as well show you now, and I'll probably do it on a couple, is it's called interval notation. Instead of doing this, I write it like this. These answers go from -infinity to -4, parenthesis, because they don't include it, and they're the answers -2, a bracket, because it's filled in, to infinity. This is the calculus, pre-calculus way. So if you want to get a step up on the rest of the peeps, you can try it because I love it. But it just says all the answers are -4 and smaller, and also, or they're -2 and bigger. So you can try that. All right, what about an and problem? And problem, you will notice something interesting about the arrows. On the or problems, they usually point away from each other. Not all the time, but most of the time. And the and problems usually point towards each other because it's that range where they overlap. The answer is where they overlap. So let's see. First thing I would do here is go up, right? This is a half, so I'm going to divide by half, or it'd probably be easier to multiply by a 2. So if I multiply this side by 2 and this side by 2, I would get C is greater than or equal to -4. And very important that you put the and in between. Solve this one. I'm going to subtract 1. I'm going to get 2C is less than 0. So C is less than 0 because when you divide by 2, nothing's going to happen. And there it is, your answer. C is greater than -4 and it's less than 0. Those are the only answers that you can use, greater than -4 and less than 0. So what does it look like on a number line? It would look like this. It would say, all right, here's 0. Here's 1, 2, 3, 4, -4. And so now I'd say, all right, open circle at 0 and shade everybody to the left. And maybe I should make that arrow go longer. It's everybody this way, right? And then -4 is a filled in circle and everybody to the right. And you can see, interesting, that these things overlap. And in an and problem, if it says the word and in between, then you got to be very careful the way you read this. It says you have to be in both arrows. So luckily that region between -4 and 0, this region right here, that is the only answers, not the arrows continuing on. Now, heads up, for an OR problem, it would be all the answers because you could be in one arrow or the other and every number is covered. But because it's an AND problem, it's only the numbers -4 to 0. And by the way, the calculus way to write that, -4 to 0. Boom. That's it. Neat, right? So you need to be able to do this and you need to be able to do this, right? And probably the cleaner answer for this, by the way, would be -4 and 0. You know, open circle and a filled in, and you would just do that, right? Not with the arrows going off in weird directions, because and means only where they're both happening. So this would be a much prettier answer. All right. What do I got next? I got absolute value. Now, do you know what absolute value is? The most important thing to know about absolute value? It is the distance to 0. That's what the definition of absolute value is. How far away are you from 0? So absolute value problems are kind of fun because the fact is that you have to solve them twice because there's 2 distances from 0. Think of a number line, right? You got this number line, and if I say I am 3 units away from 0, you can't just assume that I am sitting right here. I could also be sitting right here at -3. So that's what makes absolute values interesting, is there's 2 answers, and I have to think of both answers. So this is what I like to do. I like to cover this part up right here, not let you see it. You don't know what's under there, right? But what do you know? You know that it's either equal to 10 or you know it's equal to -10, right? Because whatever's under that blue squiggle, if it's a 10, then the absolute value is 10 because the distance to 0 is 10. If it's a -10, well, the distance is also 0. So there you go. Now I'll reveal the surprise and tell you what is that's under there. Well, it's a -3 plus k and a -3 plus k. That's what it is, right? So -3 plus k, I'm going to add 3 to both sides. And I'm telling you right now that k could be 13, or you could add 3 to both sides and you would get k is -7. And so realize, tricky problem. Most people would think the answer was just 13. However, -7 also works. So the big trick is that you need to figure out how far it is by worrying about both positive and negative directions. Very, very interesting. When you solve these, my little hint to you here, always get the absolute value alone first. See that 6 floating around? That's a constant. Why isn't it with the 2? Because that's also a constant. They're not in the absolute value bars, so why aren't they together? That's really weird, right? So I'm going to add 6 to both sides before I do anything. Absolute value of x over 4 is equal to 4. And now I'm going to do that same thing, right? I'm going to pretend that I don't know what's here, right? And I'm going to say, well, I'm going to do it sideways. It's either equal to 4 or it's equal to -4, whatever's under there. And now the big reveal. I will look to see what is under there. And it looks to me like it is an x over 4. So now I will solve that. Multiply both sides by 4 for this one. I get x equals 16. Multiply by 4 for this one. I get x equals -16. And there's my 2 answers. So again, x can be 16 or x could be -16. Nice work. Now let me ask you a question and I'll be right back. Excellent work. All right, let's talk about absolute value equations and inequalities. This box at the top of the screen is super important. Put a little star by it. Make sure you remind yourself. But whenever you do an absolute value problem, if it's an equals sign, right, then it's obviously always going to be, always going to be an or in between. Remember we said and or is kind of important? It is. If it's an equal sign, it's always got the word or in between. If it is a less than sign, it's always got the word and in between. And if it's a greater than sign, it's always got the word or in between. Now there's one rule. You look at that once you finally get the absolute value by itself. So absolute value's got to be alone all by themselves on one side. Then you can set it up as an and problem or an or problem and solve it as a compound inequality. Now that's super important. Now it's kind of easy to remember though, because look at this. This is a less than, we said. Well, let's call it a less than problem. And let's call this one a more than or a greater than problem, right? I guess that's an and. But remember that. So you have less than or more than. So that tells you. All right, look at example 3 here. If I look at that, I got the absolute value all alone on it by itself. So that's good. I don't have to do anything yet. I could cover it up, and I'm going to decide to break it into 10 and negative 10. However, I got to decide which word goes in between. So I'm going to copy it down like before. 4q plus 2 is greater than or equal to 10. And then I'm going to do whatever word comes in between. Now, this is a greater than or a more than. So that's going to have the word or in between. And then I'm going to have negative 4q plus 2 is less than or equal to negative 10. Because remember, if you're going to put a negative, you got to flip the sign. Right? So I flip the sign and I make it negative. Now that's because the negative would have been in the absolute value bars. We would have flipped it over. But I can show you that in class on why. But it's almost easier just to remember that you make it once for greater than 10 and you make it once for the opposite. So less than 10 every time. Doesn't matter if it's or and. It's always, flip the sign and make it negative. Now solve it. So I subtract 2 from both sides and I get negative 4q is greater than or equal to 8. So q, I'm going to divide by a negative, flip the sign, less than or equal to negative 2. Or the other side, negative 4q is less than or equal to negative 12. Again, dividing by negative 4q is greater than or equal to 3. And it's an or problem. So I am completed. Now I can make this or problem. They wanted me to graph it. So the answers to this very difficult problem are negative 2, negative 1, 0, 1, 2, 3. And the q is, let's do the q is less than negative 2. That's a filled in circle and less than that. And q is greater than 3. Filled in circle and greater than that. And there's your answer for your graph. So we graphed it and we solved it. And then all you extra studs who want to go, hey, how would calculus write that? Negative infinity to negative 2 bracket with 3 to infinity. That's how they would write the solution, in case you were curious. All right, so here's the rules. Get the absolute value by itself. Then rewrite it as an and or an or problem, and then solve it. That's the steps to solving. So let's try this next one. Absolute value is not by itself, so I'm going to move the 3 over real quick. Now I'll have, that's a half. 0.5r is greater than or equal to 0. Oh, that's going to be a little tricky when I have to do the positive and the negative. All right, it's a more than problem, so it's going to be an or. So I'm going to copy it down once like it was. Or, and then I'm going to say 0.5r is less than or equal to negative 0, which sounds really silly, but that's what it would be. Now that's a half, so I'm going to either multiply both sides by 2. Say I multiply both sides by 2 and I get r is greater than or equal to 0. Or multiply both sides by 2, r is less than or equal to 0. There's your answers. Bizarre and silly, right? What does the number line look like out of curiosity? 0's on there. It's got a filled in circle. And r is greater than 0, so it's everybody that way. And then the other answers are or, all the answers are less than 0, which is that way. So do you see that that is actually every number in the world? It's all reals. So it's all reals. Or for the pre-calc people, negative infinity to infinity, that's their answer. So answer, 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 and then graph. Beautificent. Let me ask you a question, and we'll be right back. All right, nice work. Now here come our last 2 for this video. So let's go ahead and solve up example 4, and then we'll call it a day. So again, make sure you get absolute value all by itself. So first thing I would do on letter A here is I'm going to multiply both sides by 3, so it looks like this. So now I have a nice absolute value by itself, right? No constants hanging around. Now I'll break it up into a problem. That's an and problem right there because it's a less than symbol. So 2x plus 7 is less than or equal to 3. And at the same time, 2x plus 7 is greater than or equal to negative 3. Again, you're still going to do that flip and that negative or that opposite, whatever you want to call it. And now solve it twice. So I'm going to subtract 7 from both sides. 2x is less than or equal to, what is that, negative 4. And then divide by 2, x is less than or equal to negative 2. I didn't have to flip it because it wasn't a negative. And at the same time, subtracting 7, 2x is greater than or equal to negative 10, and x is greater than or equal to negative 5. Now that says that you have to pick a number, in essence, between negative 5 and negative 2. Why? Because you have to be less than negative 2, but you have to be greater than negative 5. So here's my number line. And I would have, here's negative 2, negative 3, negative 4, negative 5. Here's, negative 1 and 0. I'm going to have a filled in circle at negative 2, and I'm going to be less than that. I'm going to have a filled in circle at negative 5, and I'm going to be greater than that. And where, since this is an and problem, you have to be in both of them. Where are we with both arrows? That's only from negative 5 to negative 2. So it's just going to be like this little arc right here. Or for those of us who like to do the pre-calc method, bracket negative 5 to negative 2 bracket, finished with our answer. All right, last melon. I don't like the half sitting out in front of there, and I don't like the negative sitting out in front of there. So I got to move both of those before I can do this problem. So I'm going to multiply both sides by negative 2, and I'm going to get this. But wait, I multiplied by a negative. That flips the sign. Oh my goodness. Now it's also an and problem. So p minus 2 is less than or equal to 3. And at the same time, p minus 2 is greater than or equal to negative 3. All right, not a big deal, but a little tricky, to say the least. Add 2 to both sides. P is less than or equal to 5. And at the same time, p is greater than or equal to negative 1. And there is my solution. What does my graph look like? Well, you got to be, see, here's negative 1, 0, 1, 2, 3, 4, 5. Two numbers that I have to put on there are 5 and negative 1. This says 5 is filled in everybody below, and negative 1 says everybody filled in and above. And again, imagine these arrows, they're arrows, they go on forever, right? Like we told us in geometry, an arrowhead's going to go on forever. But we need to be in both arrowed regions. So where is that? That's just this little chunk right between the two, because it's an and problem. An or problem would have been okay, but an and problem says only right there. That's it. Have a great day. Stay happy, and I'll see you tomorrow.